I want to take some time now to go over the Lab 3 data sheet with you. Because you weren't able to perform this lab, I did record myself performing the lab. So you need to watch the recording that's provided for you in the class. And what you need to do is record the color of the flame that you observed, and you'll do that here in this color category. You'll notice you have two unknowns on here, and the two unknowns will be actually taken from the ones that you've already done. So really you need to compare your colors to determine what your unknowns are. You'll write the formula here, and the formula for each one of these is actually given for you up here on the first page. And then you need to figure out which is the metal and which is the non-metal in that particular compound. And just to give you a little hint, metals are found on the left side of the periodic table, and non-metals are found on the right side of the periodic table. Now, what you'll do from this point is you will use the visible light spectrum in order to get the wavelength for the ones where you have to record that. So what you need to do is Google visible light spectrum. And you'll find something that looks similar to this. Now let me find one that's arranged. Here we go. So you'll find something that looks like this, and you'll match the color that you saw for each of your metals to this spectrum and make an approximation of what wavelength that color is. For instance, if you had a true green color, then it's in this range right here. So we would say it's somewhere around 530 to 540. If you had red, it would be 740. If you had purple, it would be 380. So the wavelength is going to be whatever you can closely match your color to here. And notice that the wavelength is given in nanometers. So when you record on your sheet, you're going to make sure that you record this here in nanometers. Okay, and you'll do that for barium, calcium, copper 2, lithium, and your unknown number 1. Now, just to make things a little easier for you, I'm going to give you the frequency for these. So you won't actually have to go anywhere to find the frequency. So the frequency for the others, the potassium, sodium, strontium, and unknown number 2, you can just type in here as being 430 terahertz. So that's capital T, capital H, lowercase z. Okay, so all of these are going to be in nanometers, and then you're just going to repeat this 430 terahertz for these other 3 here. Now when we look at the calculations, what you're going to do is take your wavelength, convert it to meters, calculate the frequency from that, and convert that to terahertz. And I've given you some conversion factors here. And there's a particular formula that you have to use, and that's also found right up here. So this is the equation that you'll use when you're working the problems in number 1. So now I want to work an example for you just so you can understand how these calculations work. So let's say, as an example, I was given a wavelength of 600 nanometers. My first step is going to be to convert nanometers to meters, because when I'm going to use my formula that I just showed you, where c, the speed of light, is equal to wavelength times frequency, My speed of light is a constant, which is 3.00 times 10 to the 8 meters per second. So I need my unit to be in meters. So that's why I have to convert nanometers to meters. So to convert from nanometers to meters, I'm going to use my conversion factor. But again, anytime I perform any calculations or do any conversions, I always want to start with what I'm given. So I have 600 nanometers. And so I'm going to put nanometers on the bottom and meters on the top so that my nanometers can cancel. And I know that 1 nanometer is equal to 1 times 10 to the negative 9 meters. Since both of my numbers are here on the top, I multiply. And so I have 6 times 10 to the negative 7 meters. So now I've converted my wavelength into meters. Now I have to find my frequency. And frequency is represented by this kind of odd V here. In order to do that, I'm going to use my formula, C equals to wavelength times frequency. But I need to find my frequency, so I'm going to have to kind of rework this equation. So if I have C equals wavelength times frequency, but I need to solve for frequency, I'm going to divide both sides by wavelength, and so that cancels, so I'm left with C over wavelength is equal to frequency. So I'm going to solve. Now I'm going to plug those in. I'm going to say 3.00 times 10 to the 8 meters per second divided by what I just calculated as my wavelength in meters, 6 times 10 to the negative 7 meters. My meters are going to cancel out here, and so when I solve that, I get 5 times 10 to the 14, and the unit that I have there essentially is 1 over S, because I've canceled out the meters, but I haven't done anything with my second there. Well, that can also be written as S to the negative 1, which is the same thing as hertz. So essentially, I have an answer that is 5.10 to the 14th hertz. And that is my frequency. But I'm not quite done yet. Now I need to convert to terahertz. So now my third step in my problem is to convert my frequency to terahertz. So I have my frequency in hertz, 5 times 10 to the 14. I'm going to set up my conversion where I'm going to put hertz on the bottom and terahertz on the top, so my hertz will cancel. I get 1 times 10 to the 12 hertz in 1 terahertz, and my answer is going to be 500 terahertz. So that is how you work number 1 on your PostLab. Whatever wavelength you get here, whatever number wavelength you get here, you're going to plug in for these 5 and solve for frequency. Well, I gave you your frequency here, 430 terahertz, and you'll use that for number 2, and you do not have to do B, C, and D because they'll all end up being the same answer. So you don't have to worry about completing 2, B, C, or D. And in order to work problem number 2, you essentially do the opposite of what I just showed you to do. You're given 430 terahertz, so you're just going to work backwards. You have terahertz, you need to get all the way back to your wavelength in nanometers, so it's essentially opposite. So for number 2 on the PostLab, convert your terahertz to hertz. Then you use that to solve for your wavelength. You're going to use that same equation, but this time you've got to rework it to solve for wavelength. So we divide both sides by frequency. So I'm going to take C, divided by frequency in hertz, and that's going to give me my wavelength, and that's going to be my wavelength in meters. So then I take my wavelength in meters, and I convert that to nanometers. And you have all of those conversions that you need within your problem. So I hope that this helps with that data sheet and those post-lab questions. If you have any other questions, please just send me an email or a text.